Welcome back to our discussions of MySQL. Today we're going to see how you can use a select statement to work with multiple tables. So we've seen the select in a select list, and then from a from table. So our select, the columns that we want to see, and the from table, our data source. Now if we combine the from table with a join, we can now add a second table to the same query. So the select list possibilities can grow. All the columns that come from the second table as well can now be included in the select list. So how do you want to join two tables? It's very rarely just join two tables and we want to see every row matched with every row. So a join is logically connected to the very next clause, the on clause, how you want the two tables to join. This is another predicate. So just like the where is a predicate, do I want this data or do I not, the raw table data. We also seen another predicate, the having clause, which doesn't primarily work with raw table data, but instead of with the output of an aggregate function. We've seen how those work to filter data. So the on clause is another predicate. This is the clause that allows us to join one table to the other table. How do we want the table join to take place? Now let's read what this says. The join condition defines how rows from table, the first table in the from clause, and table 2 will be matched up. This is almost always an equality match. In the next two slides, we're going to see why that's true. But this greatly simplifies the understanding, in my opinion, of what's happening on the join. One thing for me, a mental block that I had, was this on clause. It's a predicate. A predicate can be very rich. It has less than, greater than, it has ands and ors. But for the most part, when we're joining two rows from two different tables, we're looking for an equality join. So the last sentence here, almost always an equality match. There's even a name for it, the equijoin. That's how common it is. There's very rarely a business case. We'll discuss one, but there's very rarely a business case where you want a join condition that's not an equijoin. You always want matches almost, and we'll see that in the next two slides why that is. The next thing that it's important to understand is that join and on can be repeated. So that means you can join table to table 2 on a condition, but then you can start another join clause where you're going to join that results to a third table on a condition. A fourth table, a fifth table. Indeed, there's no limit to how many tables you can join together just by repeating join and on. The proper way to think about it, however, is this table is joined to this table on a condition that's almost always an equality match between the two rows. That then forms a temporary table. If you have another join clause, that temporary table, that intermediate result, is then joined to the third table, which produces yet another temporary result that can then be joined to a fourth table, and so forth. So we'll first look at two tables joined together, and then we'll look at some with three tables and maybe four tables joined together in our system. So let's take a look at this Venn diagram here. So the first type of join that we're going to look at is called the inner join. It gets its name from this Venn diagram. The rows from two tables that have a commonality. So the red area in this Venn diagram is how the rows will be matched up in an inner join. So the Venn diagram suggests other possibilities, and we'll look at those. And those are covered by the outer join. So remember, the first join we're going to look at is the inner join, where you have exact matches. Then we'll look at the outer join. Keeping this Venn diagram in mind will greatly help you understand what's happening with the inner join. Also, understanding that's an equality match will also greatly simplify the mental picture for you. Now let's take a look at the enterprise relationship diagram that we discussed when we first started talking about this particular database and introduced Workbench to you, MySQL Workbench. All right, Suppose we want to produce a packing slip for an order. So we have our order information table here with the order date, required date, ship date, status, and so forth, comments. And you can see how all those would be relevant for a packing slip. What date did the customer make the order? What date was it shipped? What date did the customer require it to be there? All of that information could be on a packing slip. But what about the order details? Those would be the specific items that were contained in the orders. We want to match that up in the same query for this, in order to produce our packing slip or our invoice. So from the order details come from the individual line number. What was the product code? How much was it ordered? What did they pay for it? And what is the order line number? 1, 2, 3, 4. Right? Well, how do you join up information now for our packing slip between these two tables? A join comes into play, and an on clause comes into play. Well, how do you match these two? Think about it. Look what's here. You're going to match order number and an order number. So an order table, the orders table, joined with orders detail, the on clause being where order number equals order number. It's hard to think of a case where greater than or less than or even an ands and or come into play here. The on clause is almost always an equijoin where order number matches order number. The other two things about the joins, as we've said, you can join 3 tables, 4 tables, 5 tables, and that involves this wheel here, right? How these tables are related to one another. You can also see how the packing slip might involve customer information. Maybe you want the sales representative name on the invoice or the packing slip. That depends on your business needs. And all of these would be accomplished by doing multiple joins in the same query to pull all that information together. But the way to think about those joins is not as a group of joins, let's say 4 tables joined together, but how 2 tables are matched, this table joined with this table on this condition, which then forms a temporary table, which is then joined to, let's say, a third, and so forth. Almost always an equijoin. So we could have the orders for our packing slip, then the order details, and those are the line numbers in the order details. Suppose, though, you want to have the product name on the packing slip and other information, maybe just the product name. Put that on the packing slip, and maybe you want a description of the product line as well. That would be another join. So here, a join between order and order details on order number. But then, how do you join order details to a product? Well, what it suggests itself, the product code. And again, an equijoin. What order detail line, the row, coming from the row from the order detail, matches with the product that formed that order line? And then, what part of the product line is it for? So we've wheeled around in here, joining orders to order details, joined to products. But think about it as you're designing these queries as 2 tables at once that are joined together, and then a third table is joined to the result of that, and so forth. With a temporary table acting as the intermediary between these steps. The temporary table we never see. It's kept temporarily on the SQL machine itself. In the next lecture, we'll see several examples of inner joins in action. Join me then.